Hello, Miss Thinker here, your daily source from mind-blowing facts, forgotten history, and powerful motivation. Today, I will talk about what happens when a star eats a planet. Have you ever looked up at the night sky and wondered about the fate of the countless worlds out there? We often think of stars as benevolent, life-giving beacons, but the universe is a place of immense power and constant change. Sometimes this change is catastrophic. Today, we're diving into one of the most dramatic events in the cosmos: what happens when a star eats a planet. Imagine a solar system much like our own, with planets orbiting a central star. For billions of years, this cosmic dance is stable. But stars, like all things, have a life cycle. As a sun-like star begins to run out of hydrogen fuel in its core, it enters its final dramatic phase. It starts to swell, expanding into a red giant. Its outer layers stretch millions, even billions of kilometers into space, engulfing everything in their path. For the inner planets, this is the beginning of the end. Let's witness this celestial tragedy unfold. As the star expands, its photosphere, its visible surface, creeps closer and closer to the innermost planet. The planet's atmosphere is the first to go, stripped away by the intense stellar winds and blistering heat. The surface temperature skyrockets, boiling oceans, vaporizing rock, and turning a once vibrant world into a scorched, barren husk. The planet is literally being cooked from the outside in. But the real drama begins when the planet makes physical contact with the star's outer layers. You might think it would be instantly obliterated, but the process is more complex. The star's outer atmosphere, the chromosphere and corona, is surprisingly thin, less dense than the air we breathe. So instead of a sudden explosion, the planet begins a long spiraling journey inward, like a marble circling a drain. As the planet plunges deeper, it encounters incredible friction from the stellar plasma. This friction, or drag, is immense. It rips and tears at the planet, pulling it apart piece by piece. The planet's orbital energy is converted into heat, causing the star to glow even brighter. Astronomers can sometimes spot this temporary brightening, a telltale sign that a star is having a planetary meal. This event is called a luminous red nova, and it's a fleeting cosmic tombstone for a lost world. The intense gravitational forces of the star, known as tidal forces, also play a crucial role. These are the same forces that cause tides on Earth, but ramped up to an unimaginable degree. The side of the planet facing the star is pulled much more strongly than the far side. This difference in gravitational pull stretches the planet, deforming it and eventually tearing it into a stream of gas and debris. The planet is literally shredded into a cosmic noodle before being completely absorbed. What happens to the planet's material? It becomes one with the star. The heavier elements from the planet's core iron nickel silicon mix into the star's convective outer layers. This process is called pollution. By analyzing a star's chemical composition, astronomers can sometimes find unusually high levels of elements like lithium, which is easily destroyed in stars but preserved in planets. Finding an excess of lithium can be a smoking gun, evidence that the star consumed one of its own children long ago. The star itself is also changed by this cosmic cannibalism. The influx of angular momentum from the orbiting planet can cause the star to spin faster. The added mass and energy can also trigger violent outbursts, launching huge plumes of stellar material into space. In a way, the planet's final act is to leave a lasting scar on its parent star, a mark that can be observed across light years of space. Now, you might be wondering, could this happen to Earth? The answer is almost certainly yes. In about 5 billion years, our own sun will begin its expansion into a red giant. Its surface will swell past the orbit of Mercury, then Venus, and eventually it will reach Earth, our planet. Our home will be swallowed and vaporized. It's a sobering thought, but it's a natural part of the cosmic life cycle. The elements that make up our world will be recycled back into the star that gave them birth. But the story doesn't end there. After the red giant phase, a star like our sun sheds its outer layers, creating a beautiful planetary nebula. At its center, the star's hot, dense core remains a white dwarf. And here's where things get even more interesting. Sometimes the remnants of consumed planets, or even planets from the outer solar system that survived, can be found orbiting these stellar corpses. Astronomers have discovered white dwarfs with atmospheres polluted by heavy elements from rocky planets. They've even detected dusty debris disks and fragmented asteroids circling these dead stars, the shattered remains of a long-dead planetary system. It's like a cosmic crime scene, allowing scientists to perform a post-mortem on a solar system and piece together the story of its violent demise. These discoveries are made possible by incredibly powerful telescopes and sophisticated techniques like spectroscopy, which allows us to break down starlight and read the chemical fingerprints of distant objects. Each observation gives us a clear picture of the dynamic and often violent nature of the universe. We see that planetary systems are not static. They are born, they evolve, and they die, often in spectacular fashion. From the temporary brightening of a star to the chemical pollution of its atmosphere, the evidence of planetary consumption is all around us. It's a stark reminder that in the grand cosmic ballet, stars are the lead dancers, and planets are at their mercy. The very star that nurtures life can, in its old age, become its destroyer. It's a fundamental cycle of creation and destruction that plays out across the galaxy. Studying these events isn't just about cosmic horror. It helps us understand the long-term evolution of planetary systems, including our own. It provides crucial context for our place in the universe and the ultimate fate of our world. Each devoured planet tells a story written in the light of its parent star. If you thought a star eating a planet was the ultimate cosmic horror, wait until you see what happens when a star meets a black hole. When a star wanders too close to one of these gravitational monsters, it's pulled into a deadly dance. The black hole's immense gravity stretches the star into a long, thin ribbon of gas, a process called spaghettification. This stellar spaghetti is then pulled into a swirling, superheated disk of material around the black hole called an accretion disk. As the gas spirals inward at incredible speeds, it heats up to millions of degrees, releasing a brilliant flare of X-rays and light that can outshine an entire galaxy. This tidal disruption event is one of the most luminous and violent events in the universe. The star is not just eaten. It's shredded, vaporized, and turned into a final spectacular burst of energy before disappearing forever. But the universe has more than one way to stage a grand finale. While some stars are devoured, others go out in a blaze of glory all on their own. This is a supernova, the largest explosion that takes place in space. It happens when a massive star runs out of fuel. Its core collapses under its own immense gravity, then rebounds in a cataclysmic explosion that releases more energy than our sun will in its entire lifetime. For a brief moment, it can outshine its entire galaxy. But this isn't just destruction, it's also creation. The incredible heat and pressure of the explosion forge heavy elements like the iron in your blood and scatter them across the cosmos. We are, quite literally, made of stardust. Thank you so much for joining us on this journey into the heart of a star. If you found this cosmic tale as fascinating as we do, make sure to like this video and subscribe for more deep dives into the wonders of the universe. See you next time!